ahead and look at 2.6 today. I think that a lot of you had success in 2.5 when we were looking at solving one-step equations involving addition or subtraction. Today is going to be very similar, but the idea instead of addition and subtraction is to look at solving equations using multiplication or division. Okay? And just like in the last section, we want to go ahead and solve equations using inverse operations. So as my goal right here, I have that we are going to discuss solving equations using inverse operations right here. Okay? So to get started here, what we need to start looking at is to say, well, if I'm looking at solving equations with inverses, our first statement up here says to undo multiplication, you must, and everybody's got down that we're going to divide. Okay, division is an inverse operation for multiplication. So obviously in the next one, to undo division, you're going to write down you must multiply. Okay. So we'll jump right into this right here and look at some examples of solving equations. First one I'll have you write down here is something to the effect of, oh, how about 3x equals negative 27. Okay, so in a statement like this right here, excuse me, in a statement like this right here, what this is really saying is 3 times a number right here, 3 times some number is equal to negative 27. Now some of you might mentally say, well, that value is just negative 9, but what I really want to start looking at is process or procedure for solving this stuff today. And if I say 3 times some number right here, again, our goal is to try and isolate this variable x. So if I say I want to get x alone right here, I'm looking at this as operations. I have x times 3. So what do I want to do here? Well, I want to try and get rid of multiplication of 3. So you guys just got done telling me that the inverse of multiplication was to divide. So as I have x times 3 right here, to get my x alone, I'm simply just going to divide both sides by 3. Now how does canceling work here? Well, guys, if you look at this right here, the 3 right here and the 3 right here, 3 divided by 3 is really 1. So this really becomes 1 times x, which I can just express as x by itself. This is 1x right here. So the 3's under division really kind of cancel each other. And then I'm going to say equals on the right side, whatever negative 27 divided by 3 is. We already knew it was negative 9, so there it is. Okay, so my solution I'm looking for here, x equals negative 9. Okay, so I want to go back to a couple things here that we did in the last section. Might look better for you visually, and making sure that we're applying the same operation to both sides. So let's just go with an example like negative 6x equals negative 48. Okay. So again, I'm going to go ahead and get into that idea of drawing a line right here so I keep stuff split like that. Helps me decide whether, not really decide, but it just helps me keep operations that occur on the left side also occurring on the right side. So it kind of splits it evenly and nicely for me. So negative 6 times x. I want to undo multiplication of negative 6, so we're going to divide by negative 6. And I'm going to divide over here by negative 6. So on the left side, the negative 6's will cancel. And you're going to have x equals, I'll be careful over here, a negative 48 divided by a negative 6, going to be a positive 8. So my solution from this would be x equals 8. All right, now if I'm going too quickly for you, I have the sub pause, whatever you need to do to make sure you get this down, but just make sure you get it down, all right? Okay, let's go ahead and look at a division example. And in terms of division, what if I have something like this? How about I go x over 4, x divided by 4 is what this really says, equals, oh, I don't know, how about 23? Okay, now if you notice right in this situation right here, x is now being divided by a value. So to undo that division, we're going to have to multiply by that denominator. So I'm going to split this right here. Okay, and give me a second here to get rid of this. Go ahead and say, you know what, we're going to multiply both of these sides by 4. I have to undo division, and multiplication is what undoes my division. So over here, I've got common 4's like this. This is really a 4 and a divide by 4. Again, that's your 1. So you're going to have x on the left, and on the right, the product of 23 and 4. I'm not very good at math, but I think it's 92. All right, so we would have x equals 92. All right. So you guys take a minute right now, pause the video, and go ahead and talk with a neighbor around you and just make sure you're clear on what's going on. If you have questions, make sure you ask. I'm sure Mrs. Miller will be very helpful in here as well today. Okay? All right. Let's go ahead and look at the second page then. Up top, we've got 4 problems on your own. So we'll go ahead and pause here. You guys take a minute and go ahead and try those 4 problems on your own. And again, I'll always tell you this, once you get them done, check with a neighbor, see if you agree, and if you disagree, talk about why you disagree, okay? All right, so here we go. Okay, you should be back now. First one says 5 times x. I'll divide both sides by 5. I end up with x is equal to 9 when I do that. All right, second one, divide by -8. Both sides, and you end up with y is equal to negative divided by negative is positive, so 7. These down here are kind of hard as you look at them in the division form that they're in. Sometimes I'll rewrite this as m divided by 4 like this, equals 11. So my job is to multiply both sides by 4, and you end up with m equals 44. Okay, good one. All right, my last one right here, you have -9 equals c divided by 6. So to undo division by 6, you're going to times both sides by 6. Ooh, I messed up here. I'll do it like this. Times by 6. That's what this dot is right here. Okay. 6's would cancel, and you would have c equals, the product of -9 and 6 is -54. Okay. Give yourself a pat in the back if you got all of those correct. Okay. All right, last example is kind of a real-life example. Again, we talked about this in the last section. When we have real-life examples, we talk about how do we go about solving problems like this. And the process is really your description of how you would solve this. Problem says, suppose you work X hours and get paid $15 per hour. It says if you made $135 that day, how many hours did you work? Job is to model with an equation and solve. Now guys, as I look at this right here, well, I would simply say if I made $135 over or at a rate of $15 per hour, I would simply take 135 and divide by 15, okay? But the idea is that we're working $15, I shouldn't say that. We're working a certain number of hours at a rate of $15 per hour, okay? Our job is to figure out how many hours we work. We don't know that. That's our unknown, so I'm going to call that x. So what I'm going to say right here is this. For every hour I work, which is x, we earn $15 times the number of hours worked. So that 15 times x is going to represent our pay over x hours at a rate of $15 per hour. By the end of the day, we're going to come up with a total value of 135. Okay? So the model part is right there. Now check yourself in this situation and ask, well, did this set up nicely like we had said? Are we going to take 135 and divide by 15? Well, if I have 15 times x equals 135, to undo that multiplication of 15, you would have to divide. So to solve this right here, you're simply going to divide both sides by 15, and your x value will be 9. So how many hours did you work that day? You would say 9 hours. Okay. Sub's going to give you some assignment to work on here, quick quizzes. If you have questions, watch the video again if you need to. Otherwise, stop in the morning and see me. But I think this should make pretty much a lot of sense, as the last section was pretty much the same thing. It just involved addition and subtraction. Today we're looking at multiplication and division. So again, if you have questions, make sure you ask. But make sure you're attentive and be good to my sub. All right, have a good day.